Hey everyone, welcome to part 3. In this video, I'm going to walk you through an end-to-end DevOps project covering all the tools and concepts you should be familiar with. And no, this isn't just a list of buzzwords. You will actually see how everything fits together in practice. A quick recap. In part 1, we dug into the system design concepts. In part 2, we looked into the DevOps workflows that are part of the modern dev stack. And in this part, we'll be doing the implementation stuff. We'll cover everything from setting up your application locally using Docker Compose to provisioning your infrastructure on AWS through Terraform. Then we will trigger CI pipeline using GitHub Actions and make sure our Kubernetes cluster is in sync using Argo CD. In the end, we will also be setting up an observability stack. And on top of that, we are using Claude Code just to make sure that you are leveraging the AI tools that are available right now. And going further in part 4, we will be adding the AI layer into our automation workflow. Basically, we will be seeing AIOps in practice. Without any delay, let's get into it. Alrighty, let's get into the application. So this is my cursor setup. I use VS Code as the IDE. You have options to use different IDs as well. Plus with cursor, you can work with different models, which can simultaneously work as your agents. And in my terminal, I have Claude Code installed because I just love working with the shell. And honestly, the model intelligence is just too good to not have it right here. Few housekeeping things here. I've added a claude.md file. It just gives instruction to Claude that do all these things before doing any activity. For instance, before executing any command or taking any action, make sure you explain me, as well as make it very simple. You don't have to use any technical jargons to make it more confusing. So tell me why you are doing it, not just what. So these are some steps you can pre-configure or put as like system prompts for Claude to follow. And I love this part because at times when I'm learning something new or there's something in my code I am not aware of, it tells me about it. So this is like an iteration where you're also learning, not just applying, right? I will make sure the instructions are also in the repo for your reference. Then I also have some custom settings applied to my Claude that, okay, you can allow all these things because I feel that it's safe. And at times I don't want to keep allowing you to do something when you can do that. So these are few permissions that I have set for Claude to work on. Now you can also plug in MCP servers here. So by default, it has like Google Calendar and Gmail, but these are the MCP servers that I've added. For example, it can pull infrastructure configurations directly from AWS, like the AWS Terraform MCP server, which means Claude Code has like the real context about your cloud setup and can reason over your actual Terraform modules, not just give you generic examples that's out there on the internet. So make sure you configure the MCP servers if you want the correct data, right? Or the correct configuration you want to apply for your project. So all these setup steps would also be there in the GitHub repos. So if you're using Cursor with Claude, you can follow the same set of steps. So before we touch any DevOps tooling, let me give you a simple mind map of what we are deploying. So this is like the project structure. If you go to the projects, here is like the e-commerce microservices app. We have different components supporting different functions of the application. So I'll walk you through what services we are deploying. We're deploying auth, which handles registration and login, also issues JWT tokens, which is basically in the system design concept, I walked you around it. Like you can have all the permissions as well as the session key embedded in like a simple string. So auth does that part. Then we have the product service, it manages the product catalog. Order service handles orders. User service handles user profile. And then in the front end, this is like the layout. We have the React-based app. And it is served by Nginx proxy server. We also have the database layer, which inits all the SQL scripts. So because we need to store user data, product data, and everything in the database and make it a stateful application. Then we have Prometheus and Grafana. This is our observability stack. Prometheus helps you scrape the configs, and then Grafana helps you visualize it in dashboards. We will go through it when we are in that particular section, but I just want you to have like a rough map of what this application looks like. Key thing to note here, This is a microservices-based application. And in our system design part, we did discuss the benefits of it. The major benefit is if one service crashes, it doesn't take the other one down. And if you just want to scale one service like gateway when the traffic is high, you don't really simultaneously need to scale up the order service or any other service in picture. So you are scaling it efficiently. Now let me show you our DevOps setup. So within each service, we have a Docker file. So for instance, in the gateway service, we have this Docker file. So you can see the first step is compilation. Then there is the npm run install, which compiles the TypeScript into JavaScript. Then copy gives you the compiled output. So overall, this is like a multi-stage build. The first stage installs all dependencies, including TypeScript, and then compiles the code. This is like the front end code. Now, this is just the Docker file for the gateway service. Similarly, we have Docker files for each of the services. So for instance, if you go to auth, there'll be a Docker file. It does the same. It uses a base image, then does and installs a bunch of dependencies, tells it how the code needs to be built with dependencies. The long story short here is all these Docker files helps you create like the application image specific to that service. Similar to this, we have in front end, we have our own Docker file. This is our front end app. So it will run the React code, install all the dependencies, compile it, and then give us the front end image. Now, one of the things with front end is that it is different from all the other backend based services. Here, it is just single stage. React compiles to static files. This command is helping it serve as a static file. This single flag that you see is important here. It means any unknown route falls back to the index.html, which is how React router handles client-side navigation. So if it doesn't get the application file, it will route back to the index.html file. In our first section, we will be deploying everything locally. In order to do that, we are using Docker Compose. This is the Docker Compose file. Now, what does Docker Compose does here? We could have deployed this locally using Kubernetes, but we really want to test the images first before we make it more Kubernetes ready. So think of Docker Compose file as like the local orchestrator. It is like mini Kubernetes for your laptop. It is lightweight and you can spin up your containers, test it locally, see how the development is. A lot of developers do this, right? Like they use Docker Compose locally to check how the application looks and what's like the end-to-end process. Once that's done, that's when things are deployed in QA or staging or then further in production. So this is like the first step, deploy things locally, and then we will move into our next step. That is provisioning infrastructure on AWS. This is our Docker Compose file. I'll just walk you through what this does. First is our PostgreSQL database. This is the first service that gets deployed. This is one database server, but we are going to create 4 databases inside it. AuthDB, ProductsDB, OrdersDB, and UsersDB. Each service owns its own database. That's the microservices pattern. They don't share tables. They have separate databases for each service within the main database. Then we have the Prometheus and Grafana services. It has like its own volumes in place. Now this is the observability stack. Prometheus is our metrics collector. It pulls the Prometheus, it pulls like the open source Prometheus latest image, exposes port 9090. When you hit localhost colon 1990, you will see a Prometheus UI. And then what it also does is it mounts your local Prometheus YAML config into the container. Now that file tells Prometheus what to scrape. Basically your boutique app services it needs to scrape. And then it stores all the metric data into a named volume, which is the Prometheus data. This is the named volume where it will store all the metrics. Now this path stores where all the time series database lives. Similar for Grafana, this is the visualization layer. It pulls from the Grafana open source image, the latest image, sets up the environment variable. So when you will log in into the Grafana dashboard, this is what you will be using. Further, it gives you like where the pre-configured dashboards are located. That is basically in the Grafana provisioning folder. So we have specific configs already loaded for this project. So you don't have to go into the dashboard and create the graphs yourself. There are pre-configured, but that doesn't mean you cannot create your own dashboards. This is just for reference, like you can see things live when the application is. Now we have the gateway layer. Now this is the piece. Remember in my first part, I said that gateway is like the centralized layer or like the front end door for your application. Services talk to each other using the service name as the host name. Now Docker handles that DNS. And in this gateway layer, you will have to set these environment variables. Basically, this would be the auth service URL, this would be the product service. So whenever a request comes in, it goes to gateway. Gateway inspects this URL and then it forwards that request to the respective service. So when a request comes in to localhost 3002, it goes to the auth login page. Every service has its own port and its own service name. And when a request comes in through the gateway, it gets forwarded to the respective service. Similarly, we have configuration for each of these services, the auth, the product, the order service. We have set the environments, we have set like what the base image would be, what it needs to build, and like what services it can communicate with overall. So for instance, if you can see, the order service communicates with auth service and product service. So we have baked those URLs into it. So let's start deploying. Let's get into the folder. Now let's deploy a few things to see things in action. Checks dash boutique microservices. It will open that directory. Now we need to run a few commands to spin up the application. First, we will do npm install. This will help in building the React application. So all the dependencies are up to date and now you can run build. Now this will compile the React and create the static HTML, CSS and JavaScript files. So what this did, it built both the front end as well as the backend services. Now we are going to run docker compose up dash build. This is going to build the containers once the images are up. Now you see there was an error because I did not start the Docker client. So Claude Code helped me figure that out rather than giving me just an error code, right? So let me starting the Docker engine. This is active now. You can install Docker client in like during the prerequisites. It is going to be a part of your README. Now I will run the Docker compose up again. Mr. D. And now you'll see all the containers coming up. I'll let it access it only once, not every time. So you can see all the containers are coming up now. In a few minutes, we'll check if everything is up. I'll put this as in the editor mode so that you can see clearly what we are doing. So you can see here, we have all our images built, gateway, auth, product service, orders, user service, order service. Now let's just do Docker PS. Such a clean representation. But we do want to see if our application is active. So let me run localhost. Remember, we have our service in port 3000. Ooh, look at this. This is our application which is up and running. We have everything in this. We have like our products, and then we have our orders, like which will take you through the sign-in page. This is the authentication. This is the profile. So you need to sign in. Like application is ready. Now we can also check if our Prometheus and Grafana stack is active, right? So let's go back to this. Our Prometheus is running on 9090 host. So this is our Prometheus dashboard. We'll also test if what was the port for Grafana? Our port was 3007. So we have local host 3007. And we have we'll just put the login password. And it'll ask us to do it like for now, I'll just put the same to show you that our Grafana dashboard is active. This was just step one, where we wanted to see if our application looks exactly how we want it to look in our production systems. So key point to note here is developers normally they test using Docker containers locally before they push changes, because most of the applications are containerized, they are microservice based. So Docker makes it very easy to do it. And Docker Compose Up helps you spin everything together, making sure like the dependencies are in place and the order is in also place, because you may need PostgreSQL deployed first before you deploy the product service for the other services, right? So that's a key thing to note out of this section. One of the key reasons companies move to Kubernetes is because for now, these are like just 7-8 containers that we are deploying. But what if we need to scale those containers? And if one container dies, like you, me, the developer, we have to be on call or keep looking at it to spin it back again, right? So the self-healing, the auto-scaling capabilities, all that comes with Kubernetes. And that's why we need to move to Kubernetes in like our future sections. But our next section here is to deploy the whole infrastructure on AWS using Terraform. Now, since we have already tested our application, now we can just spin down all the services. Let's just root docker compose down. It will just ask. I'm going to say, don't ask me again because I trust you here. All the 10 containers are stopped and removed. Now, the next section is about provisioning the whole infrastructure. So you go back to your folder under your projects, click on infrastructure. This is where the whole Terraform environment lives. So the first thing we are going to look into is main.tf. If you can see in that main.tf file, everything has modules written on it. The module structure really helps you make your main.tf file a little less cluttered with all the configurations. What it does is that instead of having one giant file, we have split infrastructure into specific modules. So you have like a VPC module, you have an EKS module, you have an ECR module. Similar to that, we have Argo CD module. So VPC module spins up all networking, VPC, subnets, internet gateway, route tables. Then we have the EKS. This is where your Kubernetes cluster and worker nodes are spun up, right? Like this helps you provision all the EKS cluster specific resources. Then we have our ECR module, which helps you spin up all the image registries and like one per service as well. We are keeping it separate. Then you have the Argo CD. What this module does is it installs Argo CD and also installs the Q Prometheus stack via Helm right inside the same Terraform apply. So if you want to go further, this is where the Argo CD main file is. You will see like all the different resources that it deploys. And this is where it does like the Helm release part of deploying the Prometheus stack. So you see everything becomes so clean using modules. And one of the main key things to note here is that we are not running Helm install manually. If you don't know what Helm is a package manager for Kubernetes. It helps you deploy, manage, version complex Kubernetes resources in deployable units called charts. So you can see here it will go look for this particular Helm chart within this repository. Now, another key thing here is that the Helm provider talks directly to the EKS cluster using the cluster token. So this is the Helm repository for Argo CD, and this is the Helm repository for Prometheus. This particular resource makes sure that Argo CD is deployed without you going and manually deploying it. Log in, and you don't need to log in into the cluster to install the Argo CD here. The Helm install would work because you have provisioned it through Terraform and you're running this resource. But that said, you can still do it. This is just an automated way of doing it. So make sure when you are reviewing this and deploying this, you're going through this config one by one. Now let's go into the EKS module and let's see what EKS module does. It deploys like the right roles, the permissions, then the cluster. This is the main part. It passes the right ARNs, the role weight. It passes the right roles. Make sure certain resources are created before this cluster gets created. So it depends on does that. The OIDC provider, this is how pods authenticate to AWS services without hard-coded credentials. Then these are the, again, different role policies that are specific to nodes. This is the node group configuration. What are the instance type that will be created and what would be the name? What are the different like min size, max size, like all the scaling configs are added here. You see every resource as like depends on, which means that this resource won't be created until these three resources are in place. It creates the EBS volume where all the data would be stored. Then this is the CSI driver. This is like one of the add-on. So basically what this does is Kubernetes needs a driver to talk to AWS EBS. Now EBS CSI add-on, what it does here is Kubernetes needs a driver to talk to AWS EBS. It's a separate service. And when a pod requests persistent storage, now without this particular add-on, the PostgreSQL stateful set can't get a volume and won't start. So this add-on is very important to be added to your config. This is basically the volume where your PostgreSQL data would be loaded. Apart from the modules, this is where we are giving the variable names, right? Like this would be the VPC name, this would be the subnet name, what would be the cluster name. So all the variable values are located in the TFVars file. Now, maybe let's run it. Let's go back to our terminal, CD projects, and now we are going into the infrastructure folder. Now you have everything locally, but how would you make sure that this cursor application or this terminal environment that you're running, your shell user, can access your AWS environment? This is where you need to make sure you have set up all the credentials, right? So when you go to your console, if you go to IAM, you can go to users, and there you can have different users and you can show like different permissions, and then you can get the security credentials from here. Once that's done, you can run AWS STS get.
So once we run that command, it will verify if we have the right credential to make all the API calls within the AWS environment. And this is a prereq. You have to run this and make sure all the credentials are set before you proceed with the next steps with Terraform. In the proceeding step, now we are going to initialize all our Terraform configs, modules, providers, and this is again a prereq. So before you run any command with Terraform, you have to run Terraform init, which basically sets up the deployment backend for you. In the next step, we are basically running Terraform plan, which is a dry run, which shows you what actually it would look like when you apply those configs. So it gives you an estimate of how many resources that would be deployed. So in our case, we will have like almost 32 resources, and this would be a mix of VPC, EKS, and all the other services that we will be using within the project. And in the end, we will be applying the Terraform templates. So this would actually deploy the resources. So this is not a dry run. So make sure you're validating the configs before you run Terraform apply. And now we wait until all the resources are provisioned through the templates.
Back after 15 minutes and we can see our resources are ready. We have our ECR repositories created. We have all the networking stack, Kubernetes stack, everything deployed. Even the monitoring stack is active now. Now, this shell cannot really connect with the Kubernetes just yet. So you need to update kubeconfig in order to access the Kubernetes nodes. So there's the command AWS EKS update kubeconfig so that you can add -- our region is US East 1 and the name of our cluster is EKS cluster. What it does is like it's going to run that command and it'll update the kubeconfig so that we can access the cluster directly. You remember with kubectl you can change the context, you can change the cluster names, and you can basically play between different clusters using the config current context command. You can change the context, basically switch the clusters and then access those clusters using your shell environment. So in EKS, a kubeconfig context is basically the entry point which tells kubectl which AWS EKS cluster to talk to and how to authenticate overall. So now if I do kubectl get nodes, it's going to get me nodes from the EKS cluster. So you see we just have one node. So you can see it's ready. Let's see if it has any pods deployed. You don't have to keep adding the cluster name here over and over again. So there are no resources deployed yet. But we also have deployed Argo CD and the monitoring stacks, which is in a different namespace. If you can see, this is all ready. And best part about Claude is it just, gives you the whole picture. Now let's go into the console and let's see what all things are deployed. So you go to VPC. VPC has the AWS demo VPC created. And then if you want to go further, it also has subnets. All these were defined in our Terraform module. Then we go back to our subnets. You can see there are 3 subnets created because we are spanning our cluster across 3 zones for high availability. And so there are 3 demo VPC subnets created. Now we also have the EKS cluster. It's active. These are like the subnets that we just saw. This is the VPC, security groups, everything created. Then we have the node group and we have one desired size as because that's what was our specified desired size. So we have one node created, which is big enough to hold all the pods. And these are the details. So basically we have our infrastructure ready. You see all these things were deployed by Helm once you run the Helm install, but we didn't run anything. We just added it to our Terraform module and it did it. When you ran Terraform apply, it by default created these resources. So that's it for our section 2, that is infrastructure provisioning using Terraform. Now we are going to trigger the pipeline. We are going to use GitHub Actions for it. We have already defined our CI pipeline here, but let me show you what we are basically doing. So we go to our GitHub Repo. This is basically our repository, and this has all the details you need to know from concepts to all the workflows that we have deployed. So feel free to look into it in detail. The key thing we want to go into is GitHub workflows, and this is our ci.yaml file. Now, every time we push to this project demo branch, what it does is this pipeline, this set of steps runs automatically. So the main job of the CI pipeline is to build a Docker image for each service and then push the Docker image to its corresponding repository. That is the main work here. Now, just to walk you through this file a little bit, this matrix strategy is an important part. What it does is GitHub Actions spins up 7 runners. You see the 7 services? It spins up 7 separate runners simultaneously, one per service. All 7 build and push in parallel because of this particular strategy. So you see the pipeline time is not like in hours, depending on your code as well, but all these services are built and pushed parallelly. So that's the main purpose of this matrix strategy. It makes it much faster than building them sequentially. And think of it like that. If each service takes like 3 minutes to build and push it to repo, it would have taken 21 minutes for this entire pipeline to run. So we save a lot of time here. Going back to step 1, what it does is like it check out, pulls the repo onto the runner. Then it sets up the AWS credentials. Now, these are the credentials which we have already configured on GitHub. Now, let me show you where these credentials are stored, because this CI workflow needs those credentials in order to post changes to your AWS environment. So if you go to settings here, this is your repo specific settings. You go to secrets and variables and you go to actions. In this actions, you can create your own repository secret. This is where I have stored all the AWS access key ID, AWS account ID, region, secret access key. Now, what are these credentials? These are the same credentials that you have under your user within your IAM role. So if you go here, all these credentials that you have here goes into your AWS secrets here within the GitHub action. Now, going back to our workflow, once the credentials are set, you have given the strategy, you have made sure that these credentials are configured, then you log into the AWS ECR, because this is where you will be pushing the images to make sure that if you don't have permission or this stage fails while configuring the AWS credentials, if this stage fails, you will not be able to go past this stage because it will error out. You don't have permissions to access the repository. So these are like the prereq steps you need to do before you build your Docker image and then you push it, right? Another step that is also active here is the update manifest steps. So whenever there is a new code, there's a new image built, it will have a separate SHA hash, right? That image will have a separate hash. Your Kubernetes manifest needs to update as well, because those are the main pods which is deploying your application. So this particular update manifest activity does that. It makes sure your manifests are also pointing to the latest image that's on ECR. And so this is the whole CI pipeline that we have created. CI is continuous integration, if you don't know. So what it does for us, that rather than an engineer going and deploying the tar file into the servers, whenever there is any code change, this CI pipeline would be triggered, which we'll see in action in a few minutes, and it would deploy to your cluster. So let's go back to our terminal. Since my remote repo is in sync with my local repo, there's literally nothing to trigger, but I can still run this command that Claude is giving me. I will run an empty commit because yes, and don't ask me again. Now I will do git push origin project. I don't want to change anything in the repo right now because I want you to see the original one. And then we'll do changes as we go to show how push triggers a CI pipeline. If you can see, the commit has been pushed and it should be active here. So if you go to actions and we'll open this, we'll wait until all the jobs are completed and then we can move on to the next step. One thing to note here, all the jobs, all the 7 services would be built and pushed simultaneously, which is a big relief. So we're almost there. All the services are ready. My last step. You can also see the logs here, what is it doing, copying, like same commands that we have in our Docker file, it's running here. How we build images and like container. How we do things locally, GitHub Actions is doing for us. So in a few minutes, we will go and see our repository is updated. So these are the 7 repositories we have. Just give it a few more minutes. Front end is taking a lot of time. Okay. Excellent. So front end is also ready. Now the pipeline is updating all the manifest. That's the Kubernetes manifest, which we'll deploy in a few minutes. And we are done. If you go to action, this pipeline has passed all the stages and we have our repo updated. If you want to check, if you refresh this, you can see this was the latest image that was created like just a few minutes back, 4:12. That's my time. So this is when this image was pushed. So we have all our latest images right now. Now we deploy everything to Kubernetes. If you see, we are going to get into the GitOps folder. And before even that, so in the GitOps folder, you can see they are all Kubernetes specific manifests. You can also see here, this is the folder, this is the manifest, opt.yaml, it has like all these manifests already created. One thing that you need to note here is if you see the image hash, this is pointing to a old hash. Let's confirm. So that's our order service and we go to our repositories, we go to order service and our latest hash ends with 69D. So this is where things are going to break. Let me show you how. So far, whatever I have in my local is pointing to the older version, but my GitHub repo was updated after the CI pipeline was triggered, right? So in case, once I'll deploy, I'll show you there would be errors. And this is the piece that I want you to understand. So I will trigger that error. But before that, this is the folder where all your Kubernetes manifest lives, your separate deployments for each of these services. And with services, I meant like microservices. And within those deployments, you also have a service. This is like of type cluster IP. This is also service type. It's for internal testing. There are different types of services, which is basically how you want to expose your application. Could be node port, cluster IP, or load balancer. And if you want to make this application external, then you deploy ingress or gateway. This is the local setup, so I haven't attached an ingress here. So for each YAML, you can see there is a deployment, there is a service for here. Now, going back to the terminal, here I also want to show you another file, which is the customization YAML. Now, why customize? So instead of running kubectl apply all the 15 separate files, this one command deploys everything for you and in the right order, the order that you have defined here. So for instance, secrets must go first, otherwise database would crash, and like make sure the order is respected. So the key command now we need to run is kubectl apply k GitOps, and you will see how the application is coming up. The namespace is ready. The secrets are created. Now let's do kubectl get pods. I've been given like the namespace because Claude does it for me. But if you can see, if I can open this, you see the error image pull because it's referring to my local manifest. So my image was updated by the CI pipeline, but it was updated on GitHub. It was not updated on local, and there was nothing that could have changed it here on this particular repo, right? This is where Argo CD will help us. Let me open Argo CD in our terminal. Let's see if Argo CD is already running. Pods -n Argo CD. So you see, these pods are already running. The server is up and running. I would open it in my browser to show you how we configure and connect it to our GitHub repo. And that connection is like the link. Basically, if anything changes on the GitHub repo, it gets applied directly to the cluster rather than me doing a git pull and then, getting the latest changes from GitHub and then pushing it through like kubectl apply command. So before accessing anything, first I need to do port forward. Let's see. Where is our Argo CD service running? We need to access the server. So we will do kubectl port forward. Basically, we want to access this service on our local host server, and I'll just give the CD. Now, what this port forward command does, right? It tunnels a port from inside your cluster to your local machine. So you can access a pod or service without exposing it publicly. You see, Claude is giving me this command, right? So which basically means that it's tunneling your inside cluster port into your local machine. So when you hit localhost 8080, you should be able to access this server. So let's start it. Yes, you can do it. Now it's running in the background. You see how Claude is suggesting me the next step as well. So before running that, let me open a browser and see if our local host is host 8080. Woohoo! Look at our Argo CD deployment. This is our Argo CD dashboard. This is beautiful. Now we need the username and password. This is why we need to run this command. Basically, we have set up this credentials. So it will just fetch it for us in real time. So you see, this is the password. We go here. Let's go back here. We do admin. Then when we do, it should let me sign in. Amazing. Look at us. We have the Argo CD connected, created. Our server is active basically. Now, if you see, there's no application here. We haven't connected any GitHub repo. This is where you need to configure a GitHub repository. So when you do a connect repo, it gives you these options. Like it basically, you can connect, you can give the name, you can give the project repository URL, and you can SSH the keys. You can do it in the UI using the GitHub app or using HTTPS. You also have option to do via Google Cloud. You can give like a repository URL of the Google Cloud. So you can use different methods, right? Like you can use via SSH, you can do via HTTPS, you can have app, Google Cloud. I'm going to do it via HTTPS. So you can say something like boutique repo. Our repository URL is this. Then my username is Vani. Now the password. What would be the password here? Here you need to generate a personal access token. How do you do it? You go to settings here and you go all the way to developer settings. Here you see personal access token. You go to tokens classic and you create an Argo CD token. Here it will ask me to sign in, so give me just a minute. And you see I have given it access to repo workflow and then update the token. So I've already created it, so I don't have to create it back again, but I just wanted to show you that you need to enter that in your password here. Connect. Connection successful. Refresh list just for the sake that it's connected. You go to applications. Now, if you see, we don't have any applications created yet. So far, we have our repository connected, but there's nothing Argo CD is watching right now, a certain application that's deployed on Kubernetes and syncing it up with the GitHub repo. You see nothing, like there's no active deployment. And if you remember, most of our services were failing because of the old image that was deployed, right? So how do we trigger Argo CD here? For that, we need to deploy an application within the environment. So this is basically the Argo CD application object. What it does, it's the kind application. How Argo CD or how Kubernetes know that this is an application? It's because of the Argo CD operator that we deployed. You remember we have a whole list of Argo CD pods and services deployed through Helm. That is what telling Kubernetes that this is what needs to be deployed if kind application is defined in your manifest. So here in this case, we have like application type. This is the name of our application and namespace is Argo CD where all our servers are deployed. And then this is the repo URL you need to keep an eye on. So whenever there's any change here, you push it. You push it to our Kubernetes cluster. And this is the server, which is running the Argo CD application. And one key thing to note here is this sync policy. I've commented this piece out, which means that if there's any change, automatically updated. No, I've kept it manual right now because I want to show you the change. But what this means is if there's any change in your cluster state versus what's on the GitHub, me as an operator or an engineer or a DevOps person, I have to go and manually push a certain button to sync it. And I'll show you how. So right now, if you see, there's no applications deployed. So let's deploy this first. So we will deploy this Argo CD application file. What's coming up? Woohoo! Look at this. This application is now deployed. But if you click on this, it's out of sync. There are bunch of services but they are all in degraded state because there's nothing running. Front end is broken, auth is broken, everything is broken. This is such a stressful thing to see, but let's go back. Now I will make this terminal as a separate window so that see the full application here. Now I will apply this and I will put synchronize. What did it do? Let's see. Let me run kubectl get pods. And Argo CD says that it's deploying a new image, or you can see it's doing something to make sure our app is not broken, so it's progressing. But let's see what's happening here. So it says that they are still in image pull off state, but there are also, if you see 15 seconds back, there was a new pod created. So all these things in the pending state are the new pods that were deployed with the latest image, not by me, by Argo CD, because it's syncing up with the GitHub repo. So we'll wait for a few until this is clear. You see, boutique is ready, PostgreSQL is ready, user service is coming up, orders is coming up, and we'll wait until all the services are ready. Let's ask Claude why it's still stuck. Maybe because we are running out of resource and we just have one node. So that could be an issue. Oops, look at this. The reason this is happening is because the authentication DB is not created. Let's check the status again. But did you see one thing? We have our PostgreSQL pod created, but all the other associated pods are failing. The reason behind it is we need to run a restore job. Now, PostgreSQL by default starts empty in Kubernetes. And unlike Docker Compose, which auto runs in its scripts, we have to manually run restore job that will bring up the database and like create sub databases which would be connected to different services like auth, order, product. So in this case, make sure all the other services are connecting to the database. Right now, it's all connection errors. You can go check it as well. Let's do kubectl logs -f. See, that is the issue. There's database connection error right now. It's not able to connect to the auth DB because it doesn't exist, which is why we will exec into our PostgreSQL pod. I'm going to show it in a separate file, new text file. This is what we are doing. We are getting inside a boutique PostgreSQL pod and we are giving like the username and password. And then we are creating these tables. This is fixing the auth schema. So if you go here, you get into database, there is a restore job. What it does, it waits until the PostgreSQL pod is ready, and then it will restore a dump. Basically, it's all the data that I have pre-populated to fit into a website. So let's first run the database restore job. You know, the best part about this entire project is like even things are failing right now during the demo. Okay, so the job is created. Restore job created the whole DB layer where we have different DBs created for our different services. Now, since this is created, we're going to wait until all the pods are up here. Instead of manually running tables, I just created it into a restore job. And here, like our restore job got created. And look at this, all our application pods are coming up. Oh, now this is a rolling update. So basically Kubernetes makes sure that your new pod is up before terminating your old pod, even if it is failing. So that's the default mode where it always makes sure that there's one application pod running before the newer version comes into action. Now look at this, auth is still failing. This is where the auth DB schema has not been created. Let me first logs F. The restores job didn't really create the auth DB. So if I show you, it did create it. I don't know why it's failing. Okay, so at least Claude gave me a good direction that it's working. Yes, let's delete the old pod and then let it connect again. Ooh, look at this. Our authentication service is up and running. This is such a beautiful sight to have. The application is finally running after breaking things. One thing I forgot sharing is like I updated the script last night. Initially, what I was doing is like manually getting into the pod and running the create table command to make sure the auth DB exists. Now it's like when you are deploying it, you just need to make sure that you run the script. And then once the PostgreSQL pod is created, you run the script, the data is loaded into the server, and then you create partitions, and post that, you will see all your pods coming up. Now let's test this service real quick. Let's see, what are the kubectl get service? Where are their gateway services running in 3001? Let me port forward my gateway first. And now we will also run our front end, and let's open our browser sync localhost. I always paste the wrong thing. Host 3001. Oh, because it's our gateway. So it's what was the it's you can test this, but let me open my local host. That is where our front end is. And here we are. This is running in a Kubernetes based cluster, and we have our products, we have our orders, we have a profile, we can sign in, we can create a new account, and we'll go through the flow in a bit when we have set the monitoring stack as well, just to see how it's coming up. Don't save. Now, one of the things that I do want to trigger again is GitOps, because I want to see what happens if I manually change something on my cluster and it's not something that GitHub shows or GitHub has in its version control phase, right? Let me delete orders. Okay, kubectl, delete deployment. It's deleted. Let's go to Argo CD. Do you see this? App health, it's out of sync. Immediately it shows that something went wrong. You come here and you will see things that's not right. It shows you that orders is out of sync to what was there in our GitHub repo. So now how do I do it? I apply only and I synchronize. And if you remember, I deleted it manually. Now if I go kubectl get deployments, orders is back. I manually deleted it. So this is the power of Argo CD. If someone accidentally deleted something on your cluster, Argo CD will make sure it brings it back into the original state. Argo CD will make sure it brings it back to the original state. So it recreated the pods and it's there, it's back. Now this is our final section where we are going to deploy our monitoring stack. Another thing that I do want to play around is if I don't want to manually go and sync it, right? What can I do? All I'll be doing is I'll uncomment this part, or I'll just comment it for now so that you guys can play around as well. And I'll push this and I will go back. Since I do everything, I'll just go and deploy just pasted it again. Let's just, no, Argo CD is updated. If you go here, this is the application, synced, refresh. Okay, this is the current state right now. It's configured, it's updated. Let's delete some other deployment. Maybe I'll delete product service this time. kubectl delete deployment product. It auto completes. See, this is the part. It will reconcile. So before even you notice, if you go here, it's already synced. Within seconds, it has deployed. You know how? I'll show you. So if we go to pods, I deleted it a few seconds back. So you see product service, this was something I terminated, and immediately a new product service, 23 seconds it came out. This is the power of Argo CD, which I love it. So right now I didn't manually go and sync it, but it automatically got synced. Now this is the final step of our deployment. Let's see if our Prometheus and Grafana services are already active, and then I'll just show you what's. So this is our boutique namespace. Let's see, Qt pods and monitoring. Prometheus pods are running, Grafana pods are running. It was deployed with the application, the GitOps application. So let's see what's the port of our services, get service. So these are the service ports. Our Prometheus stack is on 9090, our Grafana is on 80. So let's just run this port forward, both of them. This is for Prometheus and this will run Grafana. Let's just pull another tab and going back to it's port 3000. So that's our React app. This is localhost. This is our Grafana. You can get your password and your username from the credentials. This is already there. We have our setup active. Here you go to dashboards, and I've already created a config which defines all the graphs or all the different visualization maps we need in order to track our or observe our application. Now, key thing to note here when you're preparing for interviews, right? Whenever you talk about observability, there are three questions you always need to answer about running a system in production. First is the top. Second, how fast it is responding. And third, what happens if anything is broken. And this section, like observability, is all about telling you or giving that answer. If your interviewer asks you, like, if there's a component, maybe auth service, or you have seen login errors, how would you figure it out what's breaking? So you go and check the logs. This could be cloud-based logs. You go and log into the cluster and you check that particular auth service and go into the kubectl logs workflow and see what's breaking, because that will track when a user sent a request, what happened, what failed. So logs are one of the metrics, or logs are one of the components that you'll check. Next comes metrics. Now each of your services, your auth service, your front-end service, your back-end service, database, everything exposes its metrics into /metric endpoint. And this is what Prometheus scrapes. It scrapes them every n seconds and then it stores it in a time series database. And then Grafana queries that Prometheus database, and then whatever you see in the dashboard is pulled from that time series database. So all these numbers are what Prometheus is exporting or giving to us. And we can also query the Prom server directly. So localhost, it's running on 1990. Here we can do read HTTP request total. Here we can have 5m execute. Okay, excellent. You see, this is what it says, that these are the requests that's been active in the past 5 minutes. And these are the metrics that it's getting. So from /API products, this is the product service. And if I want to show you some applications of it, right? Where is our app? Let's open our app. This is a React app. Now we go to products. If I am putting this to my cart, or let me go to home, I will push my dashboard in this. You can see how these metrics are being displayed on the Grafana dashboard, right? Like what is the pod usage in the boutique namespace, how different services or pods are utilizing the resources within your environment. Then this is like, what's the restart count? So the order service restarted like 5 times. There's some error that I have to fix. But the essence here is, you can see whenever there's a request, it's getting tracked through this visualization dashboard. Now I go and I sign up. Let's see if it's working. I have to fix a few things. test@gmail.com. I'm just going to write that didn't. I should have just written it down. I agree. Create account. So let's see. The gateway, we can see a bunch of requests. I have to fix the app a little bit, but there's some issues in registration. But the essence of this is, if you go to all these apps and to these services, all the requests are being tracked on your observability stack. If I do view details, it's constantly updating in real time. I don't know why my cart is not updating. I have to fix that. Now that's our full stack we have deployed. Now we finally made it to our last section of the project. That is the observability piece. This is the most critical component of the project. Let's talk about observability. There are 3 questions you always need to be able to answer about a running system. Is the system up? How fast is it responding? And how will you know if something is broken? That's what this section is all about. So as you can see, if we look into the monitoring namespace, we have all these components, or you can say pods, already deployed. The whole Prometheus stack was deployed using Helm install. So you don't have to deploy this manually. Here the Prometheus pod helps you scrape and store metrics from your services. Then there's Grafana, which helps you visualize those metrics as dashboards. There's this alert manager pod. This sends alerts to Slack, email, PagerDuty whenever the rule fires. This is an add-on. Then there's the Kube State Metrics pod. This exposes Kubernetes object states as metrics. Pods, deployments, nodes. This is the pod that exposes the object states. So for example, what's the node state? What's the pod state? Is it running? Is it pending? This is the component monitoring it. Then you have the node exporter. This exposes host level metrics like CPU, memory, disk space, everything that is part of your host node. And then you have the main operator. This manages and configures the entire Prometheus stack via CRDs, which is the custom resource definition. It tells Kubernetes that Prometheus is a valid object. This basically tells the whole schema and the functioning of the Prometheus stack. Now, the workflow here is simple. Your application is split into different services. They all expose metrics at /metrics endpoint. Prometheus scrapes them every n seconds. It stores as time series data. Grafana queries Prometheus, and you see everything in the dashboard. Now, since we have all these pods already running, I have port forwarded the Prometheus pod to port 9090. So you can see this is the Prometheus dashboard. At the same time, let's just open our application, which is our React tab. I'll just split it here. Now, the another thing that I want to show is our Grafana dashboard. Now, I've already logged in, but if you're signing up for the first time, or if you're hitting that URL for the first time, you'll hit the login page. So you will need a username and a password, which you can get from the secrets. You can run the Kubernetes get secret command and you can get the DB password. Here we already have preloaded the dashboards with the boutique microservices config. So you can see all these requests entering in and what's happening in like the heap memory for each service. Then what's the overall pod CPU usage, which service is taking the most CPU. And then there's the similar memory usage. So you see the PostgreSQL is taking the most memory. Of course, it's a database. Service health is up. So this is what most of the teams or enterprises think about. Your availability. The system needs to be up at all times. And then it also gives how many pods were restarted, how many times the pods were restarted. Now, these were the graphs that were predefined using the configs. You can create as many dashboards as you want and pick custom metrics as well. To try around Prometheus, let's just use it here. The simplest one that you will see is rate HTTP request total, and then you can give 5 minutes. If you see, this is the metric that is being exposed to Grafana. Grafana is basically reading these numbers. So you can see the status code is 304. This is the namespace. This was a GET request. This was the instance where it's running. That's the IP. And then the container was gateway. So you can see a request was sent to the gateway. You can, again, this is the simplest. So you can also do 10, 1 minute. And you can see again, that was the only request that was sent. So at times when you don't see anything on your Grafana dashboard, you go to your PromQL or Prometheus dashboard and you write a query, and then you can see what are the different metrics that Prometheus has been collecting so far. Now let's do a test here. If you see the product page is already live, first of all, we'll go to the login page. Here's the login page. Now I can log in. Yeah, it does. And so this is the portal. Here I can view details. I can add to cart. I can view my cart, and here I can proceed to checkout. So that's the full stack. We did a lot of automation today using DevOps workflows, deployed locally using Docker Compose, provisioned Terraform using modules, automated the whole integration pipeline using GitHub Actions, and then our very own integrated Argo CD operator so that it could sync the changes from the single source of truth, that is GitHub. And in the end, we could also set up the monitoring stack using Prometheus and Grafana. Now, this can be overwhelming. So my advice to you here is pick one workflow, go through it in detail, then move on to the next workflow, but do not stop. You can find the GitHub repo with the application in the description below. Make sure you fork it, you deploy it, and if you are building this project end to end, and make sure you share your journey with others as well. Don't forget to tag me as well as put a hashtag DevOps in action so that I know you're building with me. The biggest takeaway from this particular project is that every layer has a reason. Now you know why these tools are so popular and why do you hear those buzzwords so often? Because they are automating the pipeline, they are reducing the manual work. And talking about the manual work, in the next part, we are going to add intelligence into this automation workflow. We will be leveraging LLM models to create a chat app which will help you analyze these logs using natural language search. So make sure you're tuning to that. If you found this video useful, make sure you like and subscribe, and see you in the next video.